Hello guys, in this video I am going to explain how to solve this question number 25 of chapter 7 from this book Engineering Circuit Analysis by Hayt, Kemmerly and Delvin. So the question says that it is given that the voltage across the 2 Henry inductor, it is given as VL, like it is, let me write it over here, that VL is equals to 4.3 T for 0 for this range. So when T is in between 0 and 50 milliseconds, then the voltage across the inductor, it is given as 4.3 T. Now it is also given that the IL 0.1 means IL minus 0.1 means at T equals to minus 0.1, the inductor current, the current flowing through the inductor, it is 100 microamperes. Now the question says that we need to determine the calculate the current at t equal to 0 second, 1.5 millisecond and 45 millisecond. It means we need to determine the expression of the inductor current at any t. Now for the inductor, we know that if we want to determine the current, then and we know the voltage, then the relation between the voltage and the current is that to determine the current, we need to do the integration. And integration starts from t naught to t dash, and it is vt dt plus the starting, it is I naught 0. So it means this I naught, or simply I naught, right? So this I naught, it is the initial current that is flowing through the inductor, right? So we can use this formula, right? So over here it is given that IL at t equals to 0.1, the current flowing is 100 microampere, right? Now, and it is given that VLT, it is range is starting from 0. Now the problem is, what is there in between range 0 to 1 to 0 seconds? So the question is, what is the voltage? Because we can apply the integration only for this range, right? We do not know about this. What is the voltage of the current during this range? That we do not know. So how we can determine what is the voltage across this? Now if you substitute, like in this expression, if we substitute if we at t equals to 0, our VL, it is equals to 4.3 into 0 equals to 0 volt. It means at t equals to 0, the voltage is 0 volt, and 0 volt means that our inductor, if this is our inductor, then it means that the voltage across this inductor, it is 0, and if it is 0 volt, it means that we can replace it with simply a short circuit. There is no change in the current. We know that inductor formula is V equals to L di by dt, right? And the voltage will be 0. Voltage is 0 only when the di by dt is constant. Means when there is no change in the current, then only the voltage is 0. So over here, if the voltage is 0 at t equals to 0, if voltage is 0 at t equals to 0, it means that the current through the inductor has not changed. The current that is flowing at 0.1 minus 0.1, the same current is flowing at I equals to 0, right? So simply what we can do, we can say that this is exactly the same current that is flowing at 0 seconds, right? Now having this information, once we get this information, then we can use this particular formula. How? Now if I apply this formula, so this formula will get changed. How? This formula will become IT is equals to 1 upon L. What is L? Our L is, or let me, it is 2, right? So 1 upon 2 integration. Now from T0. Now over here our T naught, it will be 0 because the range, the voltage range is starting from 0. So we will put it as 0 till T dash Vt. Our Vt is this. Vt is 4.3 T. So we will put 4.3 T and then dt. Right? So we get this. Plus I naught means current at T equals to 0. And that we already got, that I current at T equals to 0, it is 100 microampere. So simply in place of this I naught, what we are going to put? We are going to put plus 100 microampere. Right? Microampere. Now integrating this, we will get 1 by 2 integration of this 4.3 T. It will be 4.3 T square upon 2 from 0 to T naught plus 100 microhenry. Now IT is equals to 4.3 upon 4. It is T naught square, T dash square minus 0 square plus 100. So it is IT, which is 4.3 upon 4 T dash square. This is also T dash plus 100 microampere. Or simply replacing T dash with T, simply we can write that the general expression for a current, it will be this: for 0 less than T less than 50 ms. Same range that is given for the voltage, because we do not know, there may be a chance that the voltage may increase or decrease after 50 milliseconds, right? So we do not know about that. So our expression that we obtain, it is only for this range, right? So we get this. Now the question says, coming back to the question, the question says that we need to determine the current. We need to determine the current at T equals to 0, 1.5 and 45 milliseconds. Means we need to determine the current at 3 T's. One is 0 at 1.5 milliseconds and third 4.5 milliseconds. Right? Now substituting the value of T, let it be I. So substituting the value of T equal to 0 in this expression, what we are going to get, that our I0, it will be 4.3 upon 4 0 square plus 100 microampere. So it is equals to 100 microamperes, right? At T equals to 1.5 milliseconds, so it will be I 1.5 milliseconds. It will be substituting 1.5 millisecond over here, we will get 4.3 upon 4. It is 1.5 into 10 power minus 3 square plus 100 microampere. So if you solve this, you will get something like 2.41875 microampere plus 100 microampere. So it will be 102.41875 microampere, right? And now if for this, if you substitute 4.5 in this case, then you will get, so it will be 4.34 1.5 into 4.5 into 10 power minus 3 square plus 100 microampere. So it will be equals to 121.76875 microampere. So you can see that the current, because the current is increasing from 100 it has increased to 102, then to 121. So this is the answer. These are the answer to this particular question number 25 of chapter 7 of this book. So if you have any doubt, you can put it in a comment box. Do subscribe my channel and share this video with your friends and colleagues. Thank you.